As we begin taking notes for this, I want to advise that for this course, I would recommend you get a spiral notebook and just take your notes accordingly. There will be a lot of talk as the notes go on, so I wouldn't print anything off beforehand. I would just take notes as though you were sitting in a course, and that will be the best way to see, hear, do, and all that helps to retain knowledge. But if at any point along the way you watch any of these lectures and you are unsure of anything, you need some follow-up, feel free to reach out through Canvas messaging. So in section 1.0, what we're going to do is we're really going to wave our hands a lot at things. We're going to begin looking at some things that we already know and then amp them up and then apply them into some calculus concepts as we go. So what I want to do to start out this lecture, and just kind of a short lecture here for 1.0, is to look at some vocabulary and make sure we understand what that vocabulary means. And then everything we are going to do in this course is going to build and build and build until it gets to what we need. So if at any point along the way you get lost in something, please reach out and let me know, because missing those little spurts of knowledge can be detrimental as we move on into other chapters and build upon it. So the first thing I want to look at and identify is two vocabulary words. I want to look at a tangent line. The tangent line is a line that intersects. So we're just going to start with intersects, or remember that just means touches at exactly one point. And so a lot of times we look at this tangent line to a curve, for instance, and so we're trying to find the line that only touches a curve once. It's not intersecting that curve at any other point, and that's going to be important as we go on. We work with that tangent line quite a bit in calculus. And so what we need to remember is, okay, if I'm wanting a tangent line at a singular point, I'm probably going to have more information just to make sure that all of that lines up and that I'm not getting it where it intersects more than once. And so let's just kind of make a little note here that finding the slope of a tangent line we have to use the secant line. So we need to define what is a secant line. Now, a secant line is more of a pre-cal algebra concept, and the fact of it, a secant line is defined as one that intersects at 2 points. And if you think about just the basics of that, it intersects at 2 points. You can remember all the way back to your algebra days, if you have 2 points, you can create a line. That's like the minimum details or qualifications in order to find an equation of a line is 2 points. And so a secant line is more of an algebra concept. And so as we amp it up into a tangent line, we've got to know a little bit more. So before we go into this example, I want to kind of jump to another screen and let's just kind of talk and discuss tangent versus secant and have an idea of pictorially what's going on before we go into a specific. So here you can see I have the function y equals x squared drawn for us, and so I just want to kind of play around with it, and then we'll go into the example of with the 2, 4 and see what's going on with it. So here you can see I have 2 lines drawn here. So this red line here is my secant line. I can move this point down so you can see I have a linear function crossing between 2 points, and then you can see with this blue line I have a tangent function, and you can see it's only crossing the curve y equals squared at 1 point. So what we need to do is we need to take our knowledge from algebra and pre-cal of the red line and somehow create the blue line. So I want you to notice this. If I take this point B and I move it closer and closer to A, you can see that the red line is getting closer and closer to what the blue line is. And it gets closer and closer and closer. And eventually, if I get B like really close, it's almost lining up, lining up, lining up. And then eventually you can see the red line disappeared. So if I'm looking at the distance between 2 points and I find the secant line, you can see the red line's really off. But if I take the distance between A and B, and I make it move it, move it, move it, move it, move it, and I make it so close, like maybe even 0.0001, you can see like it's starting to line up with it. Now way out here, you can see it's not lined up with it, but you can see we can begin to see what's going on. So if I can take the slope between A and B, say here, I'm getting close. If I can take the slope and move it, move it, move it, and maybe find the slope between these two really close points, maybe 0.0 away, 0.01 away or 0.001 away, and I can take the slope between those two really close points, I'm starting to get the idea of that tangent line. And so obviously I don't want to calculate, math people are lazy, I don't want to calculate slope from way up here and move it really, really closer, move it over. So I'm going to do it in a more of a general sense of getting this B point really, really, really close to A, so that you can see I can begin to line those up and find the tangent between those. And so this is the concept of what I want to do, and I want to kind of squeeze from a secant line into a tangent line. So let's get back to our graph over here and see what's going on with our specific example. Now the reason I want to kind of jump down here, this is not the 0.24 is, let me kind of maneuver this a little bit. If I move this up to the 0.24, move my graph over, and you can go from the bottom up, and I start moving this around between 2 points, you can see I'm gonna have to zoom in quite a bit. That's why I kind of jump down a little bit. But again, the same thing is going to happen as I move that point closer and closer. So if I move my point B really in the correct direction, if I move my point B really close to it, it's eventually going to kind of come together. So let's jump over to the graph. So here's where we left off. So I'm going to first kind of plot this out for us so we can see a graph of what's going on. So I'm just plotting this parent function. So we have one at 2, 1, 2, 3, 4, and then at 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And quadratics are symmetrical, you know all this. Okay, so there's my quadratic. And I'm trying to create a tangent line at the 0.24. So one that's just going to touch it right there and keep on going. So what I'm going to do is I'm going to take what we just talked about and apply it here. And again, we're going to do it in a very general sense because we don't want to have to move things around and get them really, really close. And so I want to take that 0.24. And then what I want to do, if I'm moving a point, when we're looking at that B point, we're moving it closer and closer and getting closer and closer to 2.4, say like 0.01 away or 0.001 away. Let's call that generic and let's call it H away. So if I take 2 and add a small increment away from it, then that will give me that value, because if we're way up here, and I think about the distance from 2 point to up here, we're going to call that H difference away. So we're just shrinking that distance between those 2 points until we get closer and closer to being at that point. Comma, the y value for that would be whatever your x value is squared. I'm going to take those 2 points, I'm going to do my slope formula. So y2 minus y1 over x2 minus x1. So that gives me 2 plus h squared minus 4, taking your second y value minus your first y value, all over 2 plus h minus 2. Now if I use my algebra, and I'm going to tell you, the biggest hurdle that students have in calculus is their algebra. You get the calculus skill, but it's that cleanup and manipulation with your algebra skills. So hopefully those are honed in, that kind of cause you to stumble in certain problems. So I'm going to clean this up. So this gives me m equal to 2 plus h squared. If I square that out, that gives me h squared plus 4h plus 4, just foiling that out, minus 4 that we had right here, all over 2 plus h minus 2, because these parentheses aren't really adding any value to it, whereas here these parentheses were showing you were squaring the whole thing. So now if I clean this up, you can see that the 4's would cancel, the 2's would cancel, and I'm left with m equal to h squared plus 4h all over h. And that was just simplifying, combining like terms. Now if I factor out the GCF of what they all have in common, that gives me h times h plus 4 all over h. And then once you factor, don't shortcut, you can cancel these h's here. So this would give me m equal to h plus 4. And so what this is this is saying as h is getting very small, 4 plus h, or h plus 4, is a good approximation of the slope of the tangent line. So then I can just take some value and I can plug it in there as I get closer and closer together. So using what we know about the secant helps us to figure out the slope of the tangent based off our algebra skills with that m. And so when we began to look at some of this idea of the tangent and secant, it's going to draw us into our first major concept, which is going to be in chapter 1. Let's go ahead and jump into some vocabulary as we move forward with some of this. We're going to pick up 2 more vocabulary, and that's going to be velocity. Now, we pick up velocity because when we talk about velocity, this is the average velocity. And average velocity is the change, which is your triangle, that's your Greek letter delta, and so that gives you your change in position over your change in time, which is slope of your secant line. So our slope of our secant line is our average velocity. But if we're taking secant algebra concept, average velocity algebra concept, and we amp it up to calculus, we get something known as instantaneous. Instantaneous velocity is the slope of the tangent line. We're going to use this concept quite a bit as we move through these first 2 chapters. And so understanding how the secant we can turn into our tangent by the illustration and the problem that we saw right here helps us to understand how velocity is turning into your instant velocity. And so this 1.0 notes was just to give us an idea of how we can relate the 2 together, and it's going to build us into our bigger concept when we start in on 1.1 and that major concept for chapter 1. So I just wanted to kind of ease into this, show you some illustrations, and start working with it.